In this video, we're going to talk about matrix inverses and show you an example of a 2 by 2 inverse. So, what is an inverse? Well, in algebra, when we have a variable x, the inverse is something we multiply it by to get to 1. And in algebra, we know that is just going to be 1 over x. And we can write this as x times x inverse, which is this to the power of negative 1, and we say that equals 1. Well, in matrices, we do the same thing. So if we have a matrix A, we want to multiply it by something to get back to the identity matrix. And what is that thing we multiply it by? Well, it's the inverse, which we'll write as A inverse. It should be noted that just like in algebra, these are commutative. So A inverse times A should also be equal to the identity matrix. These must be similar, and we will prove that eventually. So, if a matrix has an inverse, we'll call it invertible or singular. I'll use the word invertible, but some textbooks do call it singular, so it's good to know that that is another word for it. Okay, so we'll do an example with a 2 by 2 matrix, and we have a nice convenient theorem for this. So if we have a 2 by 2 matrix A with entries A, B, C, and D, if AD minus BC is not equal to 0, then A is invertible, and we have a nice formula for A inverse. We don't have the tools yet to prove this. We'll require the next video in order to start proving it, so we'll prove this later. But for now, a couple things I want to point out. This product, AD minus BC, is something called the determinant. We won't talk about that yet, but it's good to know what a determinant is as far as a 2 by 2 matrix, and we'll introduce it later. But if the determinant is non-zero, A is invertible. So if the determinant is 0, what that means is that the matrix can have multiple solutions, and if it has multiple solutions, it can't have an inverse. So that's what that means. But let's do an example problem, a computation problem, just to see how this works. So I should just quickly go over the formula first. The formula for the inverse of the 2 by 2 matrix is going to be 1 over the determinant, which is AD minus BC. And then for the entries, we flip A and D, so we swap those two, and then we change the signs of C and B. So the A becomes a D, the D becomes an A, and then B and C both become negative. So A inverse. So A is 3274. So this means that A inverse is going to be 1 over. Okay, so we have to do AD minus BC. So A is 3, D is 4, and we're subtracting B times C, which is 2 times 7. We need to make sure this isn't equal to 0, and it's not, so we're good. And then we're going to flip A and D. So instead of 3274, the first entry will be 4, the last entry will be 3, because we flipped the 2, and then the B and C become negative. So this is negative 2 and negative 7. Okay, so this simplifies to 1 over 12 minus 14, which is negative 2. That's negative 1/2 times 4, negative 2, negative 7, and 3. And then we just simplify this down to negative 2, 1, 7 halves, and 3 halves. And this is A inverse. Okay, so what you can do to confirm that this inverse works is now we can take A times A inverse, and we can show that it equals the identity matrix. So if we have A, B, C, and D, then we can multiply it by the inverse. So this is going to be D, negative B, negative C, and A, and this is all multiplied by 1 over AD minus BC. Okay, so let's do some matrix multiplication here. So this can get pretty long, so we're going to try to fit this into this video though. So the first column, or the first entry, is going to be AD minus BC. The second entry is going to be negative AB plus BA. The bottom entry is going to be CD minus CD, and the bottom right entry is going to be negative CB plus AD, and this will all be multiplied by 1 over AD minus BC. Let's take a look here. AD minus BC, keep that in. Negative AB plus BA is 0, CD minus CD is 0, and then we also have AD minus BC as our 2 entry. Of course, this is all multiplied by 1 over AD minus BC. So when we distribute this multiplication, we see that we get 1, 0, 0, 1, which is the identity matrix. So we are good. So to prove this works, we should also make sure A inverse A is equal to the identity matrix holds. You can do that on your own. I guarantee you this works. When I said I don't have the tools to prove this, what I really mean is we don't have the tools to prove that A is invertible yet. So we'll leave that for the future. Anyways, let's do one more exercise, one more computation here. B is equal to 10, 8, 15, 12. We want to find B inverse. So the first thing we do is we check to see if AD minus BC is not equal to 0. So let's check here. 10 times 12 minus 15 times 8. That is 120 minus 120, which is equal to 0. So now what we can claim is that B inverse does not exist. I cannot spell does, so I'll just write D and E. B inverse does not exist. Okay, so that was what an inverse of a matrix is and solving 2x2 matrices. So in the next video, we'll talk more about finding inverses of larger matrices. So 3x3s, 4x4s, 2x6s, which may or may not exist, who knows. So we'll check that out next time. If you have any questions, please leave them in the comments below, and I'll answer them as quickly as I can.